Alright guys, today we're still doing section 3.2, more synthetic division, but a continuation of what we did yesterday, and some more stuff that synthetic division can tell us. What I want to do here is actually skip this warm-up and review and skip these problems. I'll talk about them in class tomorrow. But what we're going to do first is I'm going to skip to this next question here with this imaginary number. And it's asking us to evaluate. So maybe I'll write that because it doesn't say it right here. Basically, remember what that means. What we talked about from yesterday is that we're taking this and we're plugging it in for x. And so that would suck to have to FOIL all of that, especially because it's an imaginary number. So actually what we're going to do is use synthetic division. Here's what that looks like. What I'm going to start with is putting the k value, the 2 minus 4i, in the backwards L box, or 2 plus 4i, excuse me. And again, I'm going to line up my coefficients, 1, 3, negative 2, and I'm going to do synthetic division. So what does that look like when it's an imaginary with a binomial in there? Well, we're still going to do the exact same thing. So bring down the 1, and then multiply the 1 by all of this stuff, which, yes, that means you have to distribute, but when you distribute 1, it doesn't do anything. So 1 times 2 plus 4i is 2 plus 4i. And notice how I lined up my number here, my value, is because I can only add like terms together. So I'm going to end up with 5 and then just also plus 4i. You can only add like terms, you guys, so this ends up being 5 plus 4i. And so now what I have to do? Take this and multiply by this. Yes, that means you have to FOIL, so I'm going to do that kind of off to the side. 5 plus 4i times 2 plus 4i. And so when I FOIL, I get 10 plus 20i plus 8i plus 16i squared. Remember, that changes to negative 16 because of the imaginary number. So actually when I combine, I can combine my I terms and get 28i, and I can combine my 10 and my negative 16 and get negative 6. Plus 28i, and again you can only combine like terms, so combine the negative 8 plus 28i. So basically when you plug in a value that is a binomial that has an I in it, your answer is going to have a number with an I in it, or a binomial as well. So it's the same exact process as yesterday, except you can also do it with imaginary numbers. And we'll talk a little bit later about what it means to actually be plugging in imaginary numbers. But let's try the second one. So we're going to do the same thing. We're taking our backwards L box and we're putting 3 minus 2i. And I'm lining up my coefficients, 1, negative 1, and 3. Where do those coefficients come from again? This coefficient is 1, this coefficient is negative 1, this coefficient is 3. That's where those numbers come from. Draw the line, bring down the 1. When you distribute a 1 into 3 plus 2i, or 3 minus 2i, you just get 3 minus 2i. You can only combine like terms, so that gives us 2 minus 2i. And yes, I have to multiply this by this, which means I'll have to FOIL, so I'll do that off to the side. 3 minus 2i and 2 minus 2i gives me 6 minus 6i minus 4i plus 4i squared, changes to negative 4. Let's see, I'm going to combine my 6 and my negative 4 and get 2. And I'm going to combine my negative 6 and my negative 4i and get negative 10i. And then again combine, and you can only add like terms. So we end up with just 5 minus 10i. So there's my answer when I plug in 3 minus 2i to that function. Okay, so that's just a little bit of review. It's exactly the same stuff that we did yesterday, except now there's imaginary numbers, so that's fine. Let's talk a little bit about what does a remainder equaling 0 actually mean. So remember yesterday in the video what we talked about was that there was, if you get a remainder of 0, which means it divides evenly, then actually what that means, you guys, is that we get, then it's an actual 0 of the polynomial. And we have a bunch of words for the word 0. It's also called a root, an x-intercept, or a solution. Those are all synonymous words that mean the same thing. And what it means is, if you look at your graph, this number right here is a 0, and this number right here is a 0. And so what are those values where it crosses the x-axis? those values are x equals -2, that's this one, and x equals 3, that's this one. And so what it says for this example is what are the zeros of the given graph? What that means is where does it cross the x-axis? That's why it's called an x-intercept. It's also referred to as a solution or a root. It's asking where does the parabola, in this case, cross the x-axis. Those are called zeros, and we're going to use the word zeros going forward quite a bit. And then it says verify your solutions. So how do I actually verify that -2 is a solution of this graph? Well, I'm going to do -2 in synthetic division. And I'm going to try 1, -1, and -6, and see if I actually get 0. 1 times -2 is -2, which is -3, +6, 0. That means that -2 is a 0. Okay, let's also do the +3. We have another 0 over here of 3. Let's verify that one as well. That means when I use 3 in the backwards L box and go through my synthetic division, 1 times 3 is 3, that gives me 2. 2 times 3 is 6, that gives me 0. That also means that 3 is a 0. This is what it means to actually find zeros. That means that we are actually finding x values where the graph crosses the x-axis. That's really important, and that's the whole purpose of doing all of this synthetic division business, okay? There are purposes behind all this math that we're doing. So what we're finding here, anytime you get a 0 in your synthetic division, that means that that is where the graph crosses the x-axis. So that's actually what we're finding here. Very, very important stuff. The next kind of a question I can ask you, remember how yesterday we talked about in the video number 1, you can divide, and that's when you fill in the x's. A second thing synthetic division can do is evaluate. So it's a faster way of plugging in an x value and figuring out what the answer is. So number 3 is this: decide whether or not is it a 0. We are learning so much stuff that synthetic division can do, and there's all kinds of questions I can ask you, and basically you do synthetic division for every single thing. So what this question is asking is decide whether or not the given value is a 0. So we are going to have a yes or no answer for these. Okay, so we have to use synthetic division because this whole chapter is about synthetic division. We have to decide if 1 is a 0 of the polynomial. So what that means is we're going to use 1 in the backwards L box, and I'm going to use the coefficients of 2, 9, -16, and 12, and I'm going to breeze through synthetic division really quick. 2 times 1 is 2 and add. 11 times 1 is 11 and add. -5 times 1 is -5 and add. Since we have an actual remainder, this means that 1 is not a 0 of the poly. Okay, if we get a remainder of 0, that means that it is a 0. So this is a yes or no question. This one is no. Okay, so really, really simple. It's the same exact process as all the other problems that we've been doing. You're just answering a different question. So for this one, it's asking us, is 1/2 a 0 of this polynomial? So let's plug in 1/2. My coefficients are 16. Whoop, be careful, there is no x to the third, so I need to put a 0 in. And 4, and oh, be careful again, there is no x term. So be very aware of the missing terms. Remember, you always have to fill in zeros, otherwise the synthetic division won't work out nicely. Let's go through this and see if 1/2 is a 0. So do 16, half of 16 is 8, and add, half of 8 is 4, and add, half of 8 is 4 again, and add, half of 4 is 2, and add. Boom. Yes. 1/2 is a 0 of the poly. That means that the polynomial crosses the x-axis at x equals 1/2. Okay, so that means that our polynomial, whatever this graph looks like, think about this graph for a second. Not exactly sure what the shape of this is, but I know that it's going to cross the x-axis at 1/2 because the remainder there is 0. That's what this is telling us. Let's do 2 more. This one is next. Ooh, weird, an imaginary 0. That's why we practiced these. But what I'm going to do is figure out if 2 minus I, when I do synthetic division, gives me a 0 remainder. I'm going to use my coefficients, 1, -4, and 5. Going to bring down the 1. 1 times 2 minus I is 2 minus I. And add, and you can only add like terms. So now I have to do off to the side here, 2 minus I times -2 minus I. Be very careful with all those negative signs. -4 minus 2I plus 2I plus I squared. And yeah, I squared is actually -1. So -4 and -1 combine to make -5. And the minus 2I and the plus 2I cancel. So wow. Okay, this is weird. Yes. 2 minus I is a 0 of the poly. Okay, same thing, just imaginary zeros. That's why we practiced those at the beginning. 1 left. Let's do the same thing. So it's asking me, is the value 1 plus I a 0? So I'm going to do 1, 3, -1, and 1. Same exact process. Bring down the 1 to start, multiply the 1 by 1 plus I. Only combine like terms, so you're adding. And now I have to do off here to the side 1 plus I times 4 plus I. 4 plus I plus 4I plus I squared. Yes, that's -1. That gives me an answer of, when I combine my like terms and everything, 4 minus 1 is 3. I plus 4I is actually 5I. And so now we add 2 plus 5I. And now I have to do one more time another FOIL. I know it's a little bit annoying, you guys, but you're fine at foiling. Foiling is supposed to be easy. It's a little bit annoying that you have to kind of write it out. I wouldn't recommend foiling in your head on these just because of the i's. It makes it a little bit different. So 2 plus 2I plus 5I plus 5I squared. Yes, that changes the 5I squared to -5. So I'm just going to combine my like terms, and I get -5 plus 2 is -3 plus 7I. That gives me -2 plus 7I. And the fact that that is not 0 means that no, 1 plus I is not a 0 of the poly. Okay, so this is question number 3 that you'll be asked, all involving synthetic division. This entire chapter is about synthetic division, and what we're going to review in class tomorrow is all the different kinds of stuff that synthetic division can do, but here are some stuff if you forgot. First of all, what we learned on the very first day was how to divide. Remember, you do -2 in the L box, and then you just fill in your x's after you're finished. That's how to answer a question that says divide, but still using synthetic division. This one, evaluate f of k, that means you plug in 2 for all of the x's, and you can do synthetic division for that as well, and you get an actual number answer because you're just looking at the remainder. And then what we learned today is to answer the question, is it a 0 or not, yes or no? And again, you do synthetic division, you guys, but you're looking at the remainder. If the remainder is 0, the answer is yes, it divides evenly, therefore it is a 0. If the remainder is not 0, the answer is no, it is not a 0 of the polynomial. So those are 3 things, and there are even more things, believe it or not, that synthetic division is going to help us do, which we'll learn about those in the next videos, okay? Thanks for watching. Bring your questions to class tomorrow, and we're going to do the warm-up to start off with in class tomorrow, all right? Have a good night, you guys.